Welcome to this discussion of Chapter 5 on the integumentary system. The integumentary system will be our first body system discussion. Up until now, we've been dealing with the atom-to-atom continuum, looking at cells and tissues. We looked briefly at skin in Lab 2, but now we're going to be looking at our first organ, that is our integument, as well as our first body system, the integumentary system. We will be covering all of the sections in this particular chapter. We'll start off with 5.1, layers of the skin, move on to accessory structures like sweat glands and nail and hair a little bit. Then we'll talk about some of the functions of the integumentary system, some of which I think you'll find very comfortable and familiar. Maybe a couple of the functions will be brand new to you. And then finally, we'll finish up with few diseases and disorders like cancer and burns and acne and lovely things like that as we'll finish up this chapter. As we progress through this, I want you to just appreciate your skin. It does a lot more than just cover us and protect us. There's a number of other functions, and we'll get into all of that. As we move through this, I want you to appreciate all of the things that the skin does in playing a role in our homeostasis. We'll be looking a very close look at the layers of the skin, both of the epidermis and of the dermis. We'll look at some of the cells that are found in those layers as well. We'll look again at those accessory organs and structures like sweat glands, hair follicles, your fingernails. We'll look at some changes that occur in our integumentary system as we age. Again, things like cancer, wrinkles, acne, all of those fun things. And we'll finish up with a few more disorders and comments about a few other things. So skin, it is in fact your largest organ of the body. It makes up about 16% of your body weight. Of course, that's a variable number, and it covers a very large area, 1.5 to 2 square meters. So it is a very large organ, and it does some amazing things in helping to protect us, but also to secrete and create some things as well. So let's start getting into this a little bit and take a look at an image that we're going to see a number of times in this chapter, slightly different variations of the same image. You've also seen this in the lab as well. So here we're looking at the cover image of an animation that you should certainly watch. And what we're going to see, let me flip down to the, I'll stay here. What we're looking at is, this is the epidermis, where my pointer is. And we're going to take a very close look at even more details of the epidermis. And then that the dermis is deep to that. And then that is your integument. That is your cutaneous membrane. That is your skin, and made up of the epidermis and the dermis. Below that, there's another layer called the hypodermis, also referred to as the subcutaneous layer. And recall too that in lab, we learned that the epidermis, that upper layer, is composed of stratified squamous, keratinized epithelium. And we learned that the dermis, well, not exclusively, is largely composed of dense irregular connective tissue. And that finally, the hypodermis, again, not exclusively, but has quite a bit of adipose down here in the hypodermis. We also see that the dermis has all the business of the skin. It's going to contain all the blood vessels, the sweat glands, the hair follicles. There's going to be some smooth muscle in your dermis called the erector pili muscles that we'll come across in a few minutes. But that dense, irregular connective tissue with all that collagen and elastin is going to be critical to holding all of these structures within the dermis. So we'll come to all of those details as we move through this. This is a great little video that also just goes through and reminds us of those 3 distinct layers. Here's a fixed image. Again, epidermis. And remember that we don't see any blood vessels here in the epidermis. that it is an avascular layer, that all of the blood vessels are deep to the epidermis, which reminds us that those epithelial cells, those keratinocytes that are up in our epidermis, must receive their nutrients from the blood vessels below in the dermis, and that those nutrients are going to permeate through the process of diffusion, moving toward the surface. So let's dive into the epidermis. Again, this is reinforced from our lab 2, where you learned about the epidermis being composed of keratinized, stratified, squamous epithelium. And that epidermis, that keratinized, stratified, squamous, is further broken down into layers. There are either 4 or 5 layers, depending upon the type of skin that we're discussing, and let me dive into that now. Most of the skin in your body has 4 layers, and those areas that have 4 layers are referred to as thin skin. This is by far the most common kind of skin. It covers you from head to toe. Those 4 layers are as follows. We'll dive into each of these in a moment. There is the deepest layer called the stratum. Hear the word stratum or strata, we're talking about layers. Basale. Think basement or in the basal layer. Then there's the stratum spinosum. We'll see why that's called that in a moment. There's the stratum granulosum. Here we're going to see the cells becoming more granular. They're beginning to die as they move toward the surface of your body. And finally, the stratum corneum. These are completely dead cells, and these are the cells that will eventually end up in your vacuum cleaner. So most of the body skin is thin skin. We do have in a few places thick skin, and thick skin is only found in a few places on our body, famously found on the palms of your hands and on the soles of your feet. And this particular skin, not only does it have a thicker overall layer, has a 5th layer called the stratum lucidum. And that stratum lucidum, we'll see, is in between the stratum corneum and the stratum granulosum. Here are 2 micrographs side by side, and honestly, they're not as strong as I'd like them to be. Here, let's just take a look at this image on the left. And the pointer is running along, you know it, the basement membrane. And so the basement membrane is here. And then we see at the surface a relatively thin but flaky layer of the dead cells at the surface. Down here underneath, we have connective tissue of the dermis. Over here on the right-hand side, we see a very distinctive look of those swirly whirlies of the dense irregular dermis. And while it's not as obvious as I'd like it to be, there is a thicker layer of the stratum corneum in this image. Again, we'll have different pictures coming up here in a moment. So let's go through these layers. And all of the cells in all of the layers, except the stratum basale, are called keratinocytes. Keratinocytes are cells that are busy making the protein keratin. Okay. Now, keratin is a waterproofing protein. We'll be seeing a lot this semester that words that end in IN are most oftentimes proteins. So keratin is a fibrous protein. It is the main ingredient in your hair, in your fingernails, and in your skin. It gives our skin sort of a tougher outer layer, and also its waterproofing or water resistant properties. The cells down, the keratinocytes go all the way up to the top layer, and by the time they reach the outside layer are completely dead, have lost their nucleus, and again are sloughing away all day long. So we take a look at this image. The layers are very distinctive. We can see the dark pink at the top. This is the epidermis. That's going to include all of those layers. Then we have a layer of the dermis, the connective tissue. Below that, if you blew this up, you would definitely see that this is mostly adipose through here. This is the hypodermis. And then deep to your hypodermis, you're going to have skeletal muscle. Remember, skeletal muscle is composed of long cells that have a strong striation pattern within them. And we're seeing some of those skeletal muscle cells, those skeletal muscle fibers, running across the bottom of this micrograph. So let's start at the bottom, and that is with the stratum basale. These are the bottom layer. These are the cells sitting on top of the basement membrane. They're sitting above or superior to the underlying dermis. And let me just jump down and show you this in this rather large image. So here is, I'm tracing along, here's the basement membrane. It's not indicated in this picture. The single layer of purple cells are those epithelial cells making up the stratum basale. Now note that these cells look rather cuboidal in shape, but recall, as a stratified squamous epithelium, that we're not concerned with the shape of the deeper cells. We're instead only looking at the shape of the apical cell layers. And these cells at the top are clearly very flat, very squamous cells. These stratum basale cells also contain some stem cells, so that if you do cut yourself or damage your skin, some of the cells down here are able to initiate a repair process and begin to repair the damaged skin. We see two additional cells down here as well. One shown here in yellow. This is a melanocyte, and we'll see in a moment that these are the cells that give melanin or pigment to one's skin. And then there's another visiting cell here, also with the letter M, and that is the Merkel cell. And the Merkel cell is a nerve ending. It's a receptor type of cell. And this cell is able to pick up fine touch. So when you feel, for example, sheets, right? Silky sheets versus rough sheets, or you feel some sandpaper. It's a really rough or really fine sandpaper. It is these Merkel cells that are picking up that sensational difference, those tactile touch receptors, and that signal is going to travel down this nerve. And we'll learn more about that as we get to the nervous system in a couple of weeks. So that is the top layer, or sorry, the bottom layer, the most basement layer, the stratum basale. We'll come back and look at this image a number of times. Again, these are cells that are in the bottom layer. They're sitting on top of the basement membrane, and there are those Merkel cells and some melanocytes down here as well. This picture just gives us a repeat of that. Here is that Merkel cell right at the very bottom layer of the epidermis, barely projecting out of the dermis. And again, we see those cells carrying those sensations down to a nerve that will then travel to our spinal cord and our brain. We'll talk more about the nervous system and how all that works in a few short weeks. Also, those melanocytes, these are the cells that are producing melanin. You have melanin that not only gives your skin its color, but you also have different melanocytes that give your hair its color. We'll see how that works in a few minutes. And melanin also has a very important protective feature, and that is people with a darker form of melanin actually are protected against excessive UV radiation damage to the skin. So we'll look at this in a moment as well. I would never have you recognize these cells in isolation, but again, you're going to see these melanocytes sitting in the basal layer in that stratum basale. You see it here in this particular picture. It's also in the stratum basale where it meets the underlying basement membrane and the dermis, and it's in this layer that we get our fingerprints. So the formation of the ridges on your fingers, which is completely random, completely unique. No one has exactly the same exact fingerprints, but that is caused from how the dermis and the epidermis come together. In fact, let's go back up and just let me show you that just to make more sense of what I'm saying. I'm going to go up to the actual micrograph up here. And as you see, the epidermis, the darker pink, and the dermis below, that the basement membrane runs along a set of peaks and valleys. And that peak and valley interaction of the basement membrane, notice the basement membrane is not flat here at all, right? In our lab, we kind of got the idea that oftentimes the basement membrane was a flat surface, but here we see clearly that it is peaks and valleys. And this is a random orientation, and it's all about just the randomness of your epidermis and dermis interactions that cause you to have an individual fingerprint. Even identical twins have different fingerprints. Let's go down one more layer. I said down, I'm sorry, up. Let's go up one more layer, and let's get up to the stratum spinosum. Now, the stratum spinosum, the cells here have sort of a spiny projections coming from the cells, hence the name, the spiny or the spinosum. And these cells are all linked together with desmosomes. Recall, we talked about desmosomes. Those are some cell-to-cell junctions that are found between cells that are under quite a bit of stress. And these cells are certainly under stress, holding on to each other as our skin protects our entire body. There is another visiting cell here in the stratum spinosum, and those are Langerhans cells. Langerhans cells are a type of cell called a macrophage. Macro, large, phage, to eat. And macrophages are there. I keep clicking on the wrong thing. Macrophages are there to engulf, to eat up bacteria that might get down into the stratum spinosum. Also, they can help remove foreign particles. They can help also remove dead and dying, damaged cells that occur in that layer. If we take a look, before we go back up, let me say also that these keratinocytes of the stratum spinosum are beginning to make this protein keratin. Again, that water-repelling protein found in our skin. And as the cells move forward, we're going to get more and more of that keratin produced. Going up and looking at our cartoon representation, all of these lovely, plump, healthy-looking cells are in the stratum spinosum. These cells, again, are keratinocytes. They are very mitotic. They're dividing. And this particular picture, however, does not include the Langerhans cells. So just make a note that the Langerhans cells are also found within this layer, the stratum spinosum. As we move upward, we're going to see that the cells are going to go from plump, happy, metabolically active cells, and they're going to become much flatter. They're going to start undergoing that apoptosis process where they're going through a programmed cellular death. And the next layer up is called the stratum granulosum. And as the name suggests, the cells start getting these granular appearances. And let's take a look at the more detailed picture. And we will see that we start to see that grainy appearance. The cells, again, are dying. They're losing their organelles. The cells are being disintegrated. Lysosomes, recall, are going to be a very important organelle in the breakdown and the autophagy, right, the self-eating of the cell, or the process of apoptosis as it moves forward. Now, from the stratum granulosum, the cells are going to continue to move upward toward the stratum lucidum. Let me just say now, though, that the stratum lucidum is only found in the thick skin, right? We only find it in thick skin. So we're normally not going to find stratum lucidum. We're only going to see it on our palms, our soles, and those places where we have thick skin. Now, by the time we get to the stratum lucidum, these cells are dead and they have flattened out, and they have a very clear protein which is derived from the keratin, which gives this layer a very transparent, lucid, right? Lucid is a term that just means you can see through it. It's translucent, if you will, and it is a very strong barrier to the water, to our overall body. And then finally, the top layer is the stratum corneum. And if you've ever had a corn, right, that's a term that's used sometimes for a thickened area of skin. And that is where these cells are completely dead, creating a layer through which it's waterproof, making it difficult for bacteria and things to get through here. And these are the cell layers that are shedding off all the time. It takes about 4 weeks for cells to go all the way from the bottom layer to the top layer, and essentially then you have a fully new layer of skin, or at least a fully new layer of epidermis every month or so. We'll go back up and look at that cartoon representation once again. Starting at the bottom, stratum basale, single layer of cells, a relatively thick layer of stratum spinosum, healthy, fat, metabolically active cells undergoing mitosis. And then we get to the stratum granulosum. We start to see those granular organelles breaking down. The stratum lucidum, this green layer, only found in thick skin, and in our body would not appear green, but it would appear as a translucent, clear layer. And then the top layer, which to me looks like Pringles coming out of a can, these flat, squamous, dead, flaky cells make up the stratum corneum, and these cells are filled with that protein keratin and again are flaking off. As the cells move through the granulosum and to the corneum, they are also losing those desmosome structures and those hemidesmosome structures, which are holding these cells tightly together. So by the time they reach the surface, they are free to flake off, and they're no longer being held on to each other like they are down in the lower layers. So that brings us through the layers through the epidermis. Now let's head on down to the dermis. And recall, this is the deeper layer of the skin. It is primarily made up of dense, irregular connective tissue. We have fibroblasts down here that are making a fair amount of collagen, as well as a fair amount of elastin that is giving our skin some stretch, but also an incredible amount of strength from the collagen. And it also serves as an anchoring for the blood vessels and the nerves and the hair follicles and all of the other things, the nerve endings that are found in the dermis. Here's a great image to notice for the first time that while the epidermis has multiple layers, so too the dermis has 2 distinct layers. And the more superficial layer of the dermis is called the papillary layer. Again, as I travel along the basement membrane, we see that it goes up and down, peaks and valleys, and where the epidermis and the dermis are interdigitating here, that is the papillary layer. Again, this is the layer that's responsible for your fingerprints. And in the papillary layer, and you may know this, but papillary means, or papilla means, a nipple-shaped structure. So we see these nipple-shaped projections of the dermis and the the dermis and the epidermis interlocking here. And in the papillary layer, this is one place, if you zoomed in, you would not see the dense irregular connective tissue, but you would instead see the majority of that loose areolar connective tissue. So initially in lab, I don't think I gave you a specific location for where that loose areolar connective tissue was located. I said it was sort of found everywhere, and it is. But here is a beautiful place for you to sort of put a place, right, a location for that loose areolar connective tissue. It is in the papillary layer of the dermis. Now, deep to the papillary layer, we now have the reticular layer, and that is the second deeper layer of the dermis. And this is where you see the very, very characteristic swirly whirlies of that densely packed collagen. And you also can see a large number of blood vessels. Recall that the dermis is a highly vascular structure. So again, the papillary layer, the more superficial layer with that loose areolar connective tissue. And fibroblasts, we're not surprised to see fibroblasts here. And a little bit of fat, a few little blood vessels, and also in this papillary layer, there is one sort of nerve ending called the Meissner corpuscles. And in this picture, well, actually, it's coming down in a moment. We're going to see those Meissner corpuscles. These are nerve endings that allow us to feel things a little bit deeper than those Merkel cells, which were more superficial. In that reticular layer, remember reticular means a network, that's where we have that much thicker, dense, irregular connective tissue, an even greater amount of elastic fibers, a very significant amount of collagen fibers giving the strength, and this is also going to help us hold everything together. In the dermis, you can get collagen injections or retin A creams, and what those do is they help to repair the dermis sometimes. So taking a look at the layers again here, this image shows us the two distinct layers of the dermis. So that's the one major addition to this particular image. We see the papillary layer and the reticular layer. Briefly, heading down to the hypodermis. Remember, the hypodermis is not officially part of the skin. It is oftentimes presented as a layer of skin, but officially, and the way I want you to think about this, is that the hypodermis, also called the subcutaneous layer, right? Under the cutaneous membrane, that is the hypodermis. It's also referred to as the superficial fascia. That is a term that we will see and understand better in a couple of weeks. But for now, just know the hypodermis is also called the subcutaneous layer. It is directly below the dermis. It is mostly fat. There's also, to be honest, a fair amount of that loose areolar connective tissue down here as well. So the hypodermis is loose areolar and adipose. There's still a fair amount of blood vessels. It's still a vascular tissue down here, and it is insulating, it's cushioning, and is an important layer between your skin and the underlying muscle and bones. So that brings us through the layers. Let's talk about those melanocytes again, just for a moment. And that is that your skin actually is colored by a few things. There are pigments, molecules that form color in your skin. The most prevalent is absolutely melanin. Right? Melanin was made by those melanocytes, but there's also keratin. Keratin is a vitamin A derivative, and keratin, if you take a lot of vitamin A supplementation, you might notice that your hands almost turn sort of an orangey color. So keratin can give your skin a little bit of color. And then hemoglobin, that is the protein that gives your blood vessels their red color. Clearly, we have some blood vessels close to the surface of our skin, and so our skin can also get a sort of a red tone to it from the hemoglobin. So let's just take a look at the skin again, the epidermis again, and again, here is those bottom layers of the stratum basale, and here we see a melanocyte. Now, on the left, this is a melanocyte which is producing a darker color of melanin, and the melanin is released through little melanosomes. Recall, zome, right, is a little body. So melanosomes are just little vesicles that are released through exocytosis from the melanosome or from the melanocyte. And those little vesicles are going to spread up through the cell layers, giving our tissue, the epidermis, its color. In a person who has a lighter form of melanin, right, those granules are still being formed, but the color is not as significant. You and I and everyone in this audience listening right now have essentially the same number of melanocytes. The difference, though, is what form of melanin did you inherit from your parents? There's a couple different forms of melanin. There is a darker black, dark brown sort of melanin, and there's also a more Mediterranean, lighter brown form of melanin. And you owe your skin color to the genetics, to the skin color of your parents. People like myself who are very pale, we still have melanocytes. We still make melanin, but our melanin is lacking color. It's a mutation. It's basically lacking the color. And so we don't have that coloring in our skin. So to say that skin color is only skin deep is really not even true. It's more accurate to say that your skin color is just epidermis deep, right? Because everyone has the same color underlying dermis. Now, one of the really important things about melanin is that it does protect people from UV radiation, right? So UV radiation is a major source of skin cancer. We'll talk about that in a few minutes. You go outside on a warm day, or a sunny day, the UV index is higher. That UV radiation causes you to get a burn or a tan, and that has a lot to do with the melanin. People with a darker complexion are protected in part from the damaging UV radiation from the sun. But the other thing that your skin does is that UV radiation is also important in your skin for making vitamin D. And so individuals with a darker complexion actually end up making less vitamin D. As we'll see in a couple of weeks, vitamin D is important for the production of, or for bone health. And so people with darker melanin levels, while they're protected from the sun better, actually make less vitamin D, and that can lead to people with darker complexions, African American population specifically, being at higher risk for bone issues and things like osteoporosis because of that decreased vitamin D production because of the darker skin. So those melanosomes are just constantly putting out melanin, and that is what gives our skin its color. Now, if you get too much sun exposure, right? Too much sun exposure, that's going to lead to wrinkling over time. But more significantly, those UV radiation situations actually can damage your DNA. And you know from our conversation that mutations to our DNA can lead to mutations that can lead to cancer. And we'll talk about skin cancer here toward the end of this chapter. But another thing we're going to see that might be of general interest to you is that freckles are basically an irregular accumulation of melanocytes. And moles, if you have moles on your body, moles are basically large masses of melanocytes. And while melanocytes and masses of melanocytes like moles are usually just benign, slow-growing groups of cells, those moles can, with additional UV radiation, become cancerous and become a dangerous sort of cancer. So we'll look at moles here a little bit later at the end of this chapter. So that brings us to the end of this chapter. Just a mention about melanosomes and melanin. There are other disorders where there is a lack of color altogether. That's albinism. And that will lead to a deficiency in color of the skin, of the hair, and of the eyes. And then another condition, vitiligo, this is where melanocytes in some areas of the body stop producing melanin. And this is thought to be an autoimmune reaction, and that can lead to patches of color changes. And this is more obvious in people with darker complexions because the lighter color is more pronounced. But we can see this happening also in hair and skin, even in people with lighter complexions. So we've gone through the layers. Make sure you go back and review the layers of the epidermis, thick versus thin skin. Know the layers, know the cells that are visiting in those layers, the Merkel cells, the melanocytes, and the Langerhans cells. And then go down to the dermis and appreciate the two layers, the papillary and the reticular layer. Great activities here for you to label and to confirm your understanding. Let's now take a look at the accessory structures. Now, there will be sections of this that I will skip over, not have you deal with quite as much detail. But here we're going to be talking about the accessory organs of your integumentary system, specifically hair, nails, and sweat glands. So hair, right? Hair is basically a bunch of keratin, right? It's a keratin filament that's growing up out through the epidermis. It starts off down in the dermis, and we'll take a look at this. There are pieces and parts to this that I'm not going to have you worry about. So, for example, I am not going to have you learn or worry about labeling any of these particular pieces and parts of the hair. But let's just go down here and explain something to you. So here we are seeing a hair shaft. Right, so the hair is going up. It's going up through from the dermis, up through the dermis, up through the epidermis, and up to the surface of the body. At the very base of this hair, there is a papilla. Now, again, papilla means a nipple-shaped structure. We see there's this sort of this projection that goes up into the bottom of the hair. In that hair papilla, there are some nerves, and there's some blood vessels, and also down here in the papilla, there are some melanosomes, right? Some melanocytes. So when you pluck a hair, it hurts, doesn't it? And the reason it hurts is because there's a nerve ending down here that feels that tug and sends that little pain zinger as you pull that hair. Also down here, there are blood vessels bringing nutrients to the hair and all the cells here, but also there are melanocytes, and these melanocytes are going to set up the color of your hair. You might have dark hair, you might have blonde hair, you might have red hair, brown hair. And again, that's a thank you gift to your parents. It's whatever form of this hair melanin that you inherited. And as the keratin grows up through, the coloring will be from the melanin in the bottom of that hair. While we're talking about hairs too, I will point out this muscle. There is every single one of the hairs on your body, and you have hair from head to toe in every place that you have thin hair. Recall that thin hair, majority of your body has hair. Thick skin is lacking hair. So if you look at your palms and you look at the bottom of your feet, you appreciate that where your body has thick skin, you don't have hair, right? So the hairless parts of your body. But every place where you do have hair, you have a muscle called the erector pili muscle. And these muscles are smooth muscle. And these are the muscles that when you get scared, pull and cause your hairs to go erect. So every single hair in your body has its own little individual muscle that pulls when you are scared, making goosebumps, for example. This is also a good reminder while we're here that skin is our first organ that we've looked at this semester. Now recall that organs are made of tissues. So if I were to give you, let's go up and look at this picture for a second. If I were to give you this chunk of skin, right, do you agree that you can now find in it all four types of tissues? You can find some epithelial tissues easily, right, of the stratified squamous epithelium of the epidermis. You can find some connective tissue. Man, that's easy. We've got the loose areolar up in the papillary layer. We've got the dense irregular connective tissue in the reticular layer. Down in the hypodermis, we have more of that loose areolar connective tissue, and we have lots of adipose. So we definitely can find some connective tissues easily in our skin. Oh, I've already said that there's nerve endings, right? There are nerve tissues, the Merkel cells, and those Meissner corpuscles. Those are nerve tissue, and there's more nerves that travel, more nervous tissue that travels through your skin. And finally, there are muscles, right? Here is smooth muscle, all of those erector pili muscles. So again, it's just a reminder that tissues combine to make organs. If I handed you a heart in a few weeks, you would be able to identify some epithelial, connective, muscle, and nervous tissue arranged in that heart. Likewise, if I handed you a brain, a kidney, stomach, spleen, any organ I'm going to hand you in the future, you're going to be able to identify all four tissue types. Oh, let's not forget that all of our blood vessels are also lined by simple squamous endothelial cells. So there's yet another type of epithelial tissue that is located within this thing that we call an organ. Again, I'm bluing out a number of things that are not critical to our learning this semester. So I'm not going to ask you to label the different parts of the hair shaft. There's that erector pili muscle, right? The fact that we have smooth muscle, it responds to our fight or flight responses and will pull and cause our skin to stand, or our hair shafts to stand up. And it also helps to insulate us. So when we're shivering, right, we get goosebumps as well. And that also helps to create some heat and more insulation as well. Now, we all know hair grows. We're not going to worry about the 3 stages of hair growth. I do want you to know, though, that hair grows at about 1/3 of a millimeter of hair every day. On average, you are losing 50 hairs a day. That's normal. You're losing it in your hairbrush. You're losing it down the shower sink. You're losing it in your car, right? All day. You're shedding some hair all day. That's normal. But when hair loss becomes excessive, then we start to say you have alopecia. So I want you to know this term. Alopecia is excessive hair loss. And this can be from hormonal changes. Some women will have some alopecia more during pregnancy. We see alopecia more with menopause as well when those hormonal changes. Alopecia can also be more prevalent if a person is on a calorie restrictive diet. Many times people after a gastric bypass surgery or excessive weight loss will also start to have excessive hair loss and more alopecia. People who have had radiation treatments for cancer certainly lose their hair. And finally, this is largely genetic. So if your parents and grandparents had thinning hair or a lack of hair, especially male pattern baldness, those are all hereditary type things. Hair color, like I mentioned, is caused from melanin in the melanocytes down in that hair papilla. And just depending upon which form of melanin you inherited, you have different skin color or hair colors. Now, as we get older, those melanocytes start to poop out. We produce less melanin. That's going to lead to a loss of color in our hair. And first our hair sort of becomes gray, and eventually the hair will become pure white because it has completely lost any form of melanin or coloring in it. Fingernails are another accessory gland in the integumentary system. Again, I am not going to be dealing with the specific structures of the fingernails and of the nails. However, I do want you to know that the nail bed, what you see, is actually an extension of the epidermis. It is meant to protect us, right? It gives us a little more grip and some things that we can do with our fingertips. And the main ingredient of your fingertips is keratinocytes, right? We're mostly looking at dead keratinocytes and the keratin that they contained. So again, we're not going to worry about naming the specific structures here in the nail structures. Then lastly, let's get down to sweat glands. I think this is really, really interesting. So sweat glands are all over our body. They are there to help cool us off. We're going to produce sweat from those sweat glands to cool us off when we're hot. And most of our sweat glands on our body release their products through merocrine secretion. We've seen that word before, right? Remember, merocrine secretion, the cell is simply releasing the sweat. It's a very watery sweat. It's mostly water. It's going to go up through a duct and be released to the surface of the skin. But it turns out that there's two different kinds of these sweat glands. So the most typical sort of sweat gland, the merocrine secreting sweat glands, are also called the eccrine sweat glands. You have a large number of these all over your body. They are especially present in your thick skin. You have even more of these normal merocrine sweat glands in the palms of your hand, the soles of your feet, right, in your forehead. We know we sweat, right? We sweat more from our palms, we sweat into our socks, and we sweat from our forehead more significantly. These are glands that just come up from the dermis, come up through the epidermis, and come up to the surface of the body. So again, we look at this picture. These normal eccrine sweat glands, they start down in the dermis and they just come up through the duct. It coils up through the epidermis and comes up to the surface of the body. Notice that there's no hair here. These are just coming up all over your body, regardless of where your hair is. Again, even more of these on your thick skin areas. Now, the other kind of sweat gland are apocrine sweat glands. Now, apocrine, we've seen that word before, right? Apo. These sweat glands are going to release by apocrine method. Remember that apocrine is when the cell is going to pinch off a bit of its apical surface and release products. So these apocrine sweat glands are going to produce a little bit thicker sweat. And when the cells release that cellular material, it creates stuff that bacteria love. So apocrine sweat glands are the ones that are associated with the coarser hair in your body. Think pubic and axillary areas. And they're going to produce the sweat that becomes stinky. Okay, they're going to produce a stinky sweat. Let's look at those sweat glands. And in this picture, what's down here? In this picture, we're going to see that the apocrine sweat glands come up and are associated with a hair. So this is where we have more hairy parts of our body, again, sweat glands and pubic hair areas. And these sweat glands don't really form until we hit puberty. So this is why if you have a car full of 8-year-old boys and they've just come out of a sweaty soccer game, they don't really stink. But you put a bunch of teenagers who just played soccer, and those boys are reeking because they now have pubic hair, they now have axillary hair, they now have produced these apocrine sweat glands as a part of their puberty, and these are the stinky ones. And what do? we use antiperspirants, usually aluminum-based products, and what they do is they just sort of stop that sweat somewhat. They stop that and block some of the pH changes that give us that stinky stuff. Now, so those are the two normal, quote, sweat glands that create more watery solutions. Sebaceous glands are the third type of sweat gland, and they are found all over the body too, but they are producing a thicker lipid filled material called sebum. So your sebaceous glands make an oily stuff called sebum. This sebum is really important in moderation to keeping your skin moist. As we get older, we lose these sebaceous glands. That leaves our skin drier, right? And also, the sebum actually produces sort of an antimicrobial layer. So the sebum helps us fight off the bacteria that are on the surface of our body and keeps them from invading into our tissues. Again, as we get older, we lose some of that sebum, our skin gets drier, and that also makes us more prone to infections on our skin as well. These sebaceous glands are also relatively inactive during our childhood, and at puberty, we wake these sebaceous glands up, and that is where we get our oily glands during puberty. And so the sebaceous glands, look here in this picture, this is a sebaceous gland, and we see that it looks like a little sack of oil sitting right next to a hair shaft. And so these glands release their products up through the hair shaft. And remember that sebaceous glands release their products via holocrine secretion. And this is the kind of secretion we call where the whole cell dies. And so as the cell is releasing its products, it's releasing a lot of cellular debris, and that leads to these ducts getting clogged up, leading to more acne and to more boils and things like that. In this picture as well, we see here is a sebaceous gland. There's the sebum in this picture, and that sebum is going to be released and goes up right along the hair shaft. So that brings us to the end of 5.2 and a discussion of the accessory glands. Answer these few questions and make sure you understand. If I skipped it, then you don't need to worry about the question related to that material. For example, this question about the phase of hair growth, we didn't talk about that, so you're not responsible for that information. Let's get down to 5.3. These are the functions of the integumentary system. I think this will seem very, very obvious to you, but there might be a couple of surprises here. Number one, the skin certainly protects us, right? It is protecting us from wind, water. It's protecting us from the UV sunlight that can cause cancerous and DNA changes. It is really a part of our immune function in that it keeps bacteria out and other potential things that could get into our body, chemicals that could hurt us. And finally, because we're sweating all the time, it is actually helping to reduce bacterial infections on the surface of our body. Also, in our skin, we have a lot of nerve endings, a lot of sensory functions. We sense hot, we sense cold. Now, we are not going to, in this particular chapter, focus on the many different sorts of nerve endings in your skin. When we get to the nervous system, we will revisit some of these nerve endings in your skin. But just know that your skin contains nerve endings that give you senses of pain, hot, cold, vibration, pressure, right? There are different sorts of nerve endings that give you different sensations at the surface of your body. Here's a great picture, right? This doesn't say it anywhere, but this is actually thick skin. I know it's thick skin for a couple of reasons. One, I don't see any hair, any evidence of hair here. But also, if we look, here's the basement membrane that I'm tracing. This is connective tissue and dermis down here. Here's that papillary layer. And as we go up through, the stratum basale would be this basement layer. The other multiple layers would be the stratum spinosum. I see the dark layer of the stratum granulosum. And right here, see that light layer right there? That is that stratum lucidum that's only found in thick skin. And then we also see, in addition to the stratum lucidum, we also see that the stratum corneum, man, that is a very, very thick layer of stratum corneum. So this is more telling of the palms of your hand, the soles of your feet, very thick areas of your body. We know that our skin sweats when we're cold. We know too that when we're hot and when we're cold, we know that we become even less colorful, if you will. So in a person with my complexion, being as pale as I am, I have a ruddy complexion, some redness to my body because I have blood vessels toward the surface of my body, and that red color from my blood is visible through my skin. Now, on a hot day, I become even redder, even pinker, right? Because those blood vessels are going to be opening up. We're going to say they vasodilate, and they're going to open up, trying to bring more blood to the surface so we can get rid of some of that heat. And we're going to sweat as well. On a cold day, those blood vessels are going to vasoconstrict. They're going to close down. They're going to move deeper away from the surface, and blood is going to try to hold on to that heat in our skin. And so as a result, I become more pale, right, in the winter months. And when I'm cold, all that rudiness in my face, becomes more pale as the blood vessels move away. Now, as we get older, our body is less able to maintain this homeostasis. Our thermoregulation is reduced. And so, what do older people complain about? Right? I'm hot, I'm cold, I'm hot, I'm cold. They don't have the same level of thermoregulation maintaining their body temperature as easily because, again, as we get older, some things start to fall apart. Another lovely thing that's going to happen as we get older is we're going to get more saggy skin. We're going to get more wrinkles, and our skin is going to get thinner. Our hair is going to get thinner. Our nails are going to get thinner. I mean, a lot of things are going to start getting a little bit less. We're going to start producing less sweat, have less thermal regulation. We're going to produce less sebum, leaving our hair more oily, less oily and more dry. We're going to produce less elastin, making our skin a little bit more brittle, if you will, not quite as stretchy. We're going to make a little bit less collagen, which is going to make our skin thinner and more prone to damage. So all those things are things we get to look forward to as we get older. As I said, our skin is the first step in making vitamin D. There's a number of steps in making vitamin D, but the first step in making vitamin D occurs from UV radiation hitting our skin. And in the winter months, because we don't have as much sunshine here in northern climates, we are almost all vitamin D deficient. So, what do we do in the winter? We take more vitamin D as a supplement. We try to sit under happy lights, right? Lights that give us a full spectrum light so that our skin is getting some light and is able to make up some of that vitamin D. We also need other organs. We also need our liver and our kidneys to make the vitamin D in its final form. But again, the skin is the first organ that is necessary to start making vitamin D. If we don't get enough vitamin D, an absence of sun exposure and a lack of vitamin D can lead to a condition called rickets. Now, this is a very painful condition. It's seen oftentimes in children. Their bones don't develop as well because vitamin D, I haven't said this yet, but vitamin D also is important for causing your body to absorb calcium into your digestive system. So low UV light, low vitamin D means your body's getting less calcium. In young people, again, that's rickets. We don't see rickets in the Western world because, number one, we supplement our foods with vitamin D, right? So if we don't get enough vitamin D from the sun, we at least get vitamin D in our diet through dairy products, most of which are fortified with vitamin D. Elderly people also can get some vitamin D deficiencies, and that can lead to calcium deficiencies, and that can lead to problems in bone. So that can lead to osteomalacia, which is a term meaning the softening of the bones, and it can also lead to things like osteoporosis, as I mentioned earlier. African American populations and other populations with darker melanin, because they don't get as much UV radiation at the skin, make vitamin D, which makes them more prone to bone thinning disorders like osteoporosis later in life. Vitamin D also is important in many, many other things. You may have heard that during COVID, it was discovered that vitamin D deficiency was actually one of the things that was more common in people who were more affected by the COVID um, infections. And so people who had higher vitamin D levels seemed to be more protected against COVID or hard effects of COVID. And people with lower vitamin D levels were more susceptible to the complications of COVID. So it does all sorts of amazing things. So that brings us to the end of the functions of the integumentary system. And let's now jump down. Well, I know what I want to say. I just saw a question here that made me think of something. And let's go back up to a picture of a slice of skin. Sorry, I'm having to scroll quite a ways up. Here we go, right about here. This will work. So let's say you get a paper cut. Have you ever had a paper cut? We've all had a paper cut. And that paper cut, you see it, right? You see there's a little slice in your skin, but it doesn't hurt and it doesn't bleed. So what does that tell you? If you get a paper cut and you can see this, you can see that your fingertip is sliced, but it doesn't bleed and it doesn't hurt. It tells you that that cut only went down through the epidermis and did not meet up with any of the nerve endings, and certainly didn't go down into the dermis because you're not bleeding. Now, if you slice a paper cut and it hurts, but it doesn't bleed, it means that that slice hit some of those low Merkel cells in the stratum basale. And if you get a paper cut and not only does it hurt, but it bleeds, you know that that paper cut went through all of the epidermis and hit some of those blood vessels down in the dermis. So there's a very practical, everyday experience that we've had, like paper cuts. And now you can be asking yourself, okay, what levels, what layers of the skin were cut through when that paper cut occurred? Okay, so now let's finish up with some disorders, some diseases, some injury issues of the integumentary system. We're going to be talking about a couple diseases like skin cancer. We're going to talk about eczema a little bit, acne a little bit, and then we're going to finish up with burns on the surface of the body, along with bed sores and wrinkles. So we have a lot of lovely things to talk about here for a moment. Let's start off with skin cancer. You know that cancer is a genetic disease. You know that cancer is when one cell in your body loses control of its cell cycle, and oftentimes what causes that are DNA mutations from UV radiation, right? UV exposure can lead to cancerous changes in the skin. Let's talk about these three different main types of skin cancer. And while I'm not going to ask you to recognize them visually, I do want you to appreciate the differences in the three types of skin cancer. And I want you to know what cell type in the skin went crazy in forming this skin cancer. So the first is basal cell carcinoma. As the name suggests, this is a cancer that is coming from the stratum basale, right? The stratum basale is that bottom layer of the epidermis. And this is the most common form of skin cancer in the US and in most of the world. It is in places where you have had more skin exposure. So think head, neck, back of your ears, places where sometimes you can't see. And the good news about basal cell carcinoma is that it typically does not metastasize. It usually is slower growing, and it tends to, if caught early enough, be easily removed through lopping off those skin cells, or through freezing, or even some ointments. So this is a very successfully treated sort of skin cancer. Any cancer, of course, is something to be alarmed of. But if you're told you have basal cell carcinoma, and if you are catching it early enough, it usually is not a problem. Now, the second type of skin cancer is squamous cell carcinoma. Now, this one is in the middle as far as it's concerned. It tells you where it's coming from, right? It's coming from the keratinocytes of the stratum spinosum. These, again, are found where there's oftentimes more sun exposure. And the problem with this type of cancer is that it can be more aggressive than basal cell carcinoma. If not removed, if not detected early enough, it can and will metastasize, which can lead to a much nastier treatment, and much more significant consequences of that cancer type. Again, not asking you to recognize them or identify them. And then thirdly, the kind of skin cancer that you do not want to hear that you have or a loved one is melanoma. Melanoma is definitely a fast-growing, metastatic, uncontrolled kind of cancer, and it initiates in the melanocytes, right? So this is going to begin in those melanin-producing cells. Typically, a melanoma derives or starts off from a mole. And many of us have moles on our body, little spots of dark cells, little melanocytes, right? Moles are nothing more than a concentration of melanocytes, giving us a little area of skin color. And it's really important that if you start to see your moles changing their shapes or their sizes or their colors, that you seek help very, very quickly. The problem with melanoma is that, again, it's coming from a mole. So you've already had a spot on your body for years, maybe since you were a child, that had a mole. And these changes are relatively slow. And what happens is by the time people recognize that there has been a significant change, it's already too late. And this cancer has already metastasized and spread to other areas of the body. So here's the general rule. If you have any moles on your body and you see any changes in that mole in becoming less symmetric, it becomes asymmetric. If you see the borders changing or becoming irregular, if you see color splotches or differences in the color of the mole, if you see that it's getting larger, it's growing in diameter, or that it's evolving, maybe it's getting thicker or elevating, then you want to call your doctor immediately. The problem in the world is that dermatologists, skin doctors, are very busy. There are not enough dermatologists. And if you call up your dermatologist and you say to them, hey, or find one in the phone book, that makes me sound old, doesn't it, right? No phone books. But you look it up online and you look up a dermatologist and you call to make an appointment, they're likely going to tell you that it's going to be 6 months to a year to see a dermatologist. And you are going to say, no, 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 no. I am seeing symmetric changes. I'm seeing color changes. I'm seeing diameter or elevation changes in this mole. And I'm very concerned. And those will be the key words that will get you into that dermatologist very quickly to have them examine it and make sure that they can treat this mole before it does become a more significant metastatic cancer. So know the A, B, C, Ds, and E's of skin cancer. Now, in addition to cancer, there's a whole bunch of other skin disorders that dermatologists deal with. One is eczema. Eczema is an inflammatory condition. It can be from very mild to very significant. This is going to cause excessive, almost like an allergic reaction on the surface of the skin, causing rashy outbreaks. swelling, flaking, even bleeding sometimes. There's all sorts of reasons for this, underlying allergies and things like that, but that's eczema. We try to treat it with moisturizers, keep that skin moist so it doesn't flake off, some steroid creams that help to reduce the inflammation, and even some immunosuppressants if we know that it is an autoimmune response. There's also acne. We've all probably dealt with acne in some form or another. These are basically, acne is more prone where you have those sebaceous glands releasing the sebum, more prone on the face, on your back. You can get acne anywhere, but those are the more common places. We know that acne spikes with puberty and with hormonal changes as well. And this is a great video. It shows you that sebum leaving the sebaceous gland and going up to the surface. And basically, when the sebaceous gland, you see it here, here's the sebaceous gland, here's the hair follicle, and in the middle picture, we see that the sebum, remember holocrine secretion, so these are releasing products, and there can be some bacteria down here as well. And if that sebum and that block pore and those bacteria are underneath the skin, they stay white, and we call it a whitehead. And there might be some pressure or some surface signals of that whitehead as it moves toward the surface and be uncomfortable. At some point, that whitehead will break through the surface, and when it becomes exposed to the atmosphere, the whitehead will now become a blackhead. The sebum and all this cellular junk gets oxidized and it becomes dark in color. That's the difference between a whitehead and a blackhead. It's really the same process. We're just seeing it further along and in a different location. Again, you would go see a dermatologist for any of these sorts of things that are dealing with eczema or acne or skin cancer. And we're going to finish up with a significant, quick talk, but a really important talk on skin burns. So burns are a huge problem. You can lose your life from having a significant burn in your body. And we're going to see that burns come in three basic forms. There's first degree, second degree, and third degree burns. Let's take a look at the difference. Burns can be caused by heat, fire, explosions, radiation, electrical burns, chemical burns. And as a result of that damage, you're going to kill your skin cells. And it all depends upon what layers of the skin are affected. Is it the epidermis, the dermis, or both? That is going to give us different levels of a burn. The other thing that's a problem with the death of your skin is that you're now leading an opening to losing fluid from your body. So after the risk of infection, you also have a risk of losing fluid, electrolytes, dehydration, all sorts of things, which can lead to circulatory, cardiovascular failures, and even death. So let's take a look at first a diagram that you might see in an emergency room. And if a person presents in the emergency room with a significant burn, let's say a car accident or a house fire, one of the first things that they're going to determine is what percentage of that person's body has been affected by the burn. The more significant, the more the body's been affected, the more likely that person will suffer lasting or even death from this burn. And it's just a bunch of nines. They call it the figure of nines. And so the anterior chest, 9%, the abdominal area, 9%, your upper back, 9%, your gluteal area, 9%, front of your legs, 9, back of your legs, 9. You see the idea. So this is just a quick and easy way to add up the approximate percentage of the body that has been affected by the burn. Now let's talk about their classifications. A first degree burn is very superficial and it only affects a portion of the epidermis. This is going to be a little bit painful. Your skin's going to be a little bit swollen, but basically this is a sunburn. It is going to heal on its own. It is your classic first degree burn. just a sunburn. Okay, a little uncomfortable, but all is well. And you've only damaged a portion, not all, but just a portion of your epidermis. Now, a second-degree burn is when you have not only destroyed your epidermis, all of it, but you've also gone down and you've now damaged a portion, not all, but a portion of the dermis. Now, these second-degree burns are much more painful, have a lot more swelling, and the most characteristic thing that you'll see in a second-degree burn is painful blistering. So if you've ever touched a hot stove, you know you get a blister. A forehead blister might be caused by a hot heating iron, right? A straightening iron on the forehead. Anything that blisters is going to be a second-degree burn. You can get second-degree burns from the sun. Again, I'm very fair. I'm very sensitive to sun, and I have had plenty of blistering sunburns in my lifetime. And I know that when my sunburns blister, I don't have a first-degree burn, but I now have a second-degree burn. Now, these suckers hurt because recall that you've destroyed part of the dermis, and therefore you're going down and you are pissing off many of those nerve endings in the dermis. So extremely painful. Okay? And now finally is a third-degree burn. And a third-degree burn is one where it is going to now go third degree. A third-degree burn is going to go all the way through all of the epidermis and all of the dermis, destroying really the entire skin level. Now, these are very serious burns because you've now left the body open to infection and to fluid loss. But the interesting thing about third-degree burns is that they typically don't hurt too much because the nerve endings have all been destroyed in that third-degree burn. Third-degree burns are also referred to as full-thickness burns because you have fully destroyed the entire cutaneous membrane. And full-thickness burns or third-degree burns typically cannot heal on their own. It is going to require grafting. So what they'll do is they'll take some skin from another part of your body and they will put it on top of and hope that that skin will graft and will become your skin over that area. If you've ever had a significant burn, think about this for a second, or even a scab of sorts, this will make sense. Let's go through this. So first-degree burns, only affecting a portion of the epidermis, think sunburn. A second-degree burn, all of the epidermis and a portion of the dermis. Painful, blistering, still considered a partial thickness because you haven't fully gotten rid of the burn. So first and second degree burns are also called partial thickness burns. You get down to a third degree burn, again, you burn through everything all the way down to the hypodermis. The book describes a fourth degree burn, which is basically a really, really bad third degree burn. So if you were to see a really bad third degree burn and you could now see muscle and bone, some books might call it, well, this book does, a fourth degree burn. I'm not going to use that fourth degree burn classification because it's not universally used. I'm going to stick just with varying degrees of third degree burns. But again, when you get a deep cut or a deep burn and you have lost all of the skin layers, where does that scab form from? If you've ever had a deep wound, you know that the tissue regenerates from underneath and comes up, and your scab comes from the edges and closes in. Well, if you have lost all of the epidermis and the dermis, you've also lost the stem cells that are available to help repair that skin. So without the dermis and the epidermis, you can't create skin from the bottom up and you can't create skin from the edges. And so again, that third degree burn must be fixed through a grafting situation. Lastly, when you do cut yourself, your skin is typically going to regenerate and it's going to form a scar. So what is that? A scar is basically where your skin has repaired the damage, but it's never quite the same. Those fibroblasts that are down in the dermis are going to generate more collagen in the repair process. And that is never going to be quite the same arrangement of collagen as your tissue was. It's always going to leave some sort of mark, a scar of sorts. And of course, some people have, more significant scars than others. And sometimes that fibrous connective tissue and collagen is overdone. And that will lead to an overproduction of scar tissue. And we refer to that as keloids. So when you get too much scar or a raised scar, that's a keloid. And those can be problems as well. And then lastly, we can get, scars and keloids, right? So normal scarring and keloidal scarring is excessive keloids. So that does bring us to the end of, there we go. Sorry, one more thing. We've got two more things here. One is stretch marks, bed sores, and a little bit on calluses. So skin, as we get older, will thin out. We'll have less fat, likely, right? As we get older, I'm talking about really significantly older, we'll lose some of our fat stores underneath our skin. Our skin will naturally become thinner, and that leads us susceptible to bed sores or what's called decubitus ulcers. Now, these are even more common in people who are bedridden, who are in wheelchairs, and who are not able to move their body around. If that pressure is always on the same spot, that can lead to a breakdown in the skin and lose blood flow and lead to necrosis or cellular death, right, of that tissue. Again, these bed sores are sometimes considered a sign of neglect in elderly people. If you're immobile, it's important that healthcare workers are turning the body, turning the patient so that they're not sitting on the same tissue all the time. Those infections, those decubitus ulcers, can become infected. And if you're already an older person and are immunocompromised, those infections can be fatal. Stretch marks. So when you gain weight or lose weight, think pregnancy clearly, as the abdominal area stretches during pregnancy. That is going to stretch the skin. The skin and the dermis are made up of elastic fibers and collagen fibers, but there's only so much stretch that skin can handle. So when the skin gets stretched to its maximum and some of those collagen and elastin fibers are going to pull apart, that is going to leave the lovely stretch marks that are obvious. You'll also see them with rapid weight gain or even weight loss, right? You'll see it in people who work out, who have larger muscles in the shoulder or the arm, and because their muscles have stretched the skin, they literally will get stretch marks up in the shoulder and axillary region as well. And then finally, if you are constantly rubbing on your skin, like your shoes are not fitting well, and you're rubbing on your heel, you can get a callus. It's basically a thickening area of the stratum corneum. It is thought to be a protective mechanism, right? So your skin is being abrased, it's going to be rubbed on, and so the skin cells are going to trigger more division, making a thicker skin at that place. And that's not really a big deal, but calluses also will form on your fingers, any place where you're doing a lot of mechanical stress. And that is simply just a layer of extra stratum corneum. So that does bring us to the end of this chapter and to the end of this section. Make sure you're addressing these questions again, and make sure you learn everything about the epidermis and the dermis and the hypodermis and the skin that was highlighted in this presentation.